Hey guys, hope all's well. Last video we talked about algebraic fractions. Oh, by the way, do you see that? Oh, it's all backwards. See that wonderful picture right there? A student painted it for me. Very thrilled to have it. Anyway, um, in the last video we started a series on algebraic fractions where we talked about what they are, what reducing them means, how it looks when you reduce. We went from really basic to a little more complicated, and we'll revisit reducing again here in the future. But in this video, what we're going to talk about is what it means to simplify, which does entail reducing, but also moving that through to addition and subtraction, right? So let's get to it. I'm going to switch over to the document camera. I just wanted you guys to see my beautiful face and my beard in full bloom. I mean, here we are into the, oh man, what is it? Personal isolation and personal distancing, and here we are, no school, teaching from home, so I just can't go to the barber. What are you gonna do? Anyway, here we go. What we're gonna be talking about today is, let's see here. Let's see if I can get this light all set up correctly a little better here. There we go. So we're gonna be talking about algebraic fractions. We're going to be talking about simplifying them. In the last video, we talked about reducing, and what we said is you need a common factor between all terms. Terms are parts that are separated by addition or subtraction. So in this one, what we're going to be talking about is adding and subtracting algebraic fractions. Right? So let's start off with something that you might already be familiar with, like let's say 3/4 plus 1/4. Those already have a common denominator of 4, right? So you know that what you're going to do is you're really going to add the 3 and the 1. You never write it like that. You never go ahead and write that out. But when we are dealing with algebraic fractions, when we get the common denominator, that's what we really want to do. So we would skip that step there, and you get 4/4. Now, turns out this is correct, but it's not actually done, because after you're done adding and subtracting, but it's after you're done, you want to try to reduce again. You don't want to reduce before, because a lot of the times what ends up happening is you get rid of your common denominator that you just found. So let's see another example. 3/4 plus 1/2. Now, if you were just doing the simple calculation, you had this, I would tell you to think about this as quarters. That's 2/4, that's 3/4, that's 5/4, that's 5/4, or 1 1/4. But we're going to be talking about getting common denominators, and to get a common denominator, you need to find the lowest common multiple of the denominators. Right? So here we have a 4 and we have a 2. The smallest thing that they both divide into is 4. You see? Now, we're not going to write it separate. We're not going to do 3/4 plus something over 4. Right? We're going to do it all together. This is already 4, so we're going to do 3, and it's a plus, so we got plus, right? Now, we need this to be a 4. To change 2 into a 4, without changing its value, we multiply by 2/2. 2/2 equals 1. When we multiply 1, the value stays the same. It just is going to look a little different. So 2 times 1 is 2, and so what you end up with is 5/4. Boom, we're done. It's reduced, it's simplified, it's an improper fraction, but that's perfectly okay. Can't do anything else. So when we do addition or subtraction with algebraic fractions, like let's say we had this. Do you see? We already have a common denominator over 4, so this would be done. It'd be simplified. And now we want to make sure it's reduced. Turns out this one is reduced because we have 2 terms in the numerator, 1 term in the denominator. In order to reduce, all terms have to have a common factor. Here, they don't. So we're done, right? But let's talk about something like this. Let's say it's 3x/4 plus x/2. Now, we need a common denominator, and we know that denominator is going to be 4. Just like from before, right? In order to make that 4, we have to multiply this by 2/2. So what we end up with is 3x plus 2x. And it's better to write it this way. You don't really want to write 3x/4 plus 2x/4. Because it's just more writing, a greater chance to make a mistake, takes up more space, takes more time. This is not showing too little work. I think this is an appropriate amount of work. Now once again, we want to see if it's completely reduced. It is. It's an improper fraction, but there's nothing wrong with those. They deserve a little love too, right? So anyway, right there, we're done. So we're getting a common denominator by finding the lowest common multiple. That's not too bad when they're integers like 2 and 4. But let's see what it looks like if we have something, oh, I don't know, that's maybe a little bit different. So let's say we had something like 3 over x plus 1 plus 2 over x. Now we're getting into something that's a little bit trickier, right? So these two things, x plus 1, these two denominators, and x, they actually do not have a common factor. This right here is 1 more than x. The only way these would have a common factor is if x equaled 1, and it doesn't. So like this denominator is a binomial. It's got two parts, but it's x plus 1. There's nothing, you cannot divide x out of this. If you did, you get 1 over this if you divided x out. But you can't. I mean, you don't want that. So they don't have a common denominator. So our denominator is going to be this. These are called what's the word? Relatively prime. So the lowest common multiple of relatively prime numbers will be their product. So anyway, no common factor, x and x plus 1. We need to make this have a denominator of x times x plus 1. So what it's missing is just x. Yeah? So 3x. And you see, this is the same as this right here, right? Now, this is missing x plus 1. So we have to multiply by x plus 1 over x plus 1. Now, a really common mistake people do is they write 2x and then they write plus 1. But it's really, you have to multiply 2 times the whole thing, so it's going to be plus 2. Now, after you got all that done, all you got to do is combine like terms. So we have 5x, 3x and 2x is 5x plus 2. You do not need to multiply the denominator. In fact, it's probably a best practice not to multiply the denominator. Now let's check if there's anything that can be reduced. Here we have a factor of x and a factor of x plus 1. This has got a factor of 5x, that's just 2. There's not a common factor between all of the terms, so we can't reduce, and it's done. That's really all that's involved with addition and subtraction. It does get a little trickier though, especially with subtraction. So let's see the same exact question, or the same exact problem, with a minus sign right here. This is where people get in a lot of trouble. So if you see algebraic fractions that are being subtracted, you need to slow down, be very, very careful, because what's going to end up happening is this negative is going to create a sign. You're not going to distribute the negative a lot of the time, and you're going to make a serious mistake, get yourself all kind of confused. So just like before, our common denominator is going to be the product of those two things, right? And we have to multiply that by x over x, no big deal. And this one by x plus 1 over x plus 1. Here's the deal though. It's a negative 2. It's not a positive 2 like it was up here. It's a negative 2. So what we really have is we have negative 2 times x plus 1. It's supposed to be a 2. And so that gives us negative 2x minus 2. You see? And what everybody always, the most common mistake right here is people are going to write a plus 2. And it's a minus 2. The reason it's a minus 2 is because we're subtracting this. You see? So 3x minus 1 is x minus 2, and x times x plus 1. Done. Can't be simplified, can't be reduced, because there's not a common factor between all of the terms of the numerator and the denominator. So we are finished right there. Can't get any better. Beautiful. All right. Now, last one. Sometimes what you're going to end up wanting to do is you're going to want to end up factoring the denominators to see if they really have a lowest common multiple that's something other than their product. So for example, if we had 3 over 8x minus 2 over 3x squared, do you see? We could say the denominator is going to be 24x cubed, just the product of those two. But what's going to end up happening is if we don't get the lowest common denominator, we are going to be guaranteed to have to reduce at the end, and that's another step. It's sometimes tricky. It's another chance to make a mistake. So it's better to just be really careful at the onset and make sure you're finding the lowest common denominator. So the lowest common multiple of 8 and 3 is, of course, 24. But x and x squared, well, their lowest common multiple is x squared. This is already x squared. We don't need to change it. We can multiply this by x to get x squared. So here's what we're going to do. To make this denominator into 24x squared, we have to multiply by 3x. Do you see? 3x times 8x is 24x squared. 3x times 3 is 9x. Now, this one, it's already got the x squared. We're good there. We have to multiply by 8 over 8. That gives us a negative 16. So let's see if there's a common factor. These have a common factor of 3. These have a common factor of 4. This has a common factor of x, but there's two terms on the top, one in the denominator, two in the numerator, one in the denominator. They do not all share a common factor, so we're done. All right, now let's see what would have happened if we didn't get that lowest common denominator. Let's say we went with this, right? So go ahead and write it over again. 3 over 8x minus 2 over 3x squared, right? So let's say we said it was 24x cubed. You can still get the right answer. It's going to be more work, right? So in order to make 8x into this, we have to multiply by 3x squared, top and bottom. That gives us 9x squared, right? And then minus, and then times 8x. 8x times 3x squared is 24x cubed. So minus 16x. Now you see this has a factor of x, this has a factor of x, and this has a factor of x. If you left this as your answer, you're going to lose credit. You're going to lose some points, at least some partial credit. So this is completely done. It's completely reduced and simplified. When you're adding and subtracting, your final answer needs to be reduced. So you need to check at the very end. So this one's not reduced. You have to factor out the x to get that. So anyway, what you're looking for is you're looking for the lowest common multiple of the denominators. Like 24x squared is the lowest common multiple of 8x and 3x squared. And then you get a common denominator. Multiply the numerator and denominator by the same thing, because it's really over 1, just like you did with regular fractions from back in 5th grade. And then you just combine like terms in the numerator, and you're done. Anyway, I hope that was helpful. In the next video, what we're going to be talking about is we're going to kind of continue to take the next step with reducing things that are a little bit trickier that involve more factoring. And then we're going to talk about how to solve some equations that involve these algebraic fractions. Anyway, I hope it's been helpful. Here, I'll give you a couple practice problems. See how you guys can do. Oh no, the next video we're going to talk about multiplication and division. I lied. You'll have to forgive me. Boy, I wish we were in school right. If we were in class right now, if you're one of my students, you know I would blame a student. I'd say, I confess, it's Johnny's fault or something like that. All right, so here, let's try a couple of these. You can, if you're in my class right now, you can submit answers or questions about these in Google Classroom. You can send me an email. You can also leave your answers down below as a comment. Either way, let me know what you think. I would like to help you out. This is a tricky topic at first, but once you get the hang of it, it's actually really easy, and it doesn't really need to be a barrier. It doesn't need to be something that's impossible. It's something that's very doable. So anyway, hope it's been helpful, and hope to see you guys soon. Talk to you later.